In this video, we are going to discuss the quadratic function in vertex form and the transformations that can be done using all possible parameters. So that's our A, P, and Q. So transformations. And transformations just mean uh, like how you move it. And just vertex form. So our function looks like this. A bracket x minus p squared plus q. And we will now just use a general equation. Let's say y equals, I have one written here, so 2 bracket x plus 1 squared minus 4. That's what I got. Okay, cool. So let's do the graph over here. So minus 4 and 1 means I kind of want it like this. So this is my y, this is my x. So let's read our vertex. Our vertex is -1, -4. So we go -1 and 1, 2, 3, 4. So right at the bottom here. And let's write that -4. So it's sometimes hard to write with Sharpie. But now let's do a bit of a table of values. So x and y. So if x is -1 right here, we know we get -4 out. So we can put that first. -1 and we get -4. So what happens if x is 0? So we put a 0 in here. That's just 1, and 1 squared is 1. But then we times it by 2, so that's 2, and then -4. So if x is 0, we get -2. Now if x is 1, that's 2. 2 squared is 4, times 2 is 8, minus 4 is 4. So what we have then is how the graph looks this way. So we go 0 and -2, and then when we hit 1, we're actually at 4. It's right at the top of the graph over here. Now, this has an axis of symmetry, right? Like right down here. Our axis of symmetry. So if we just draw this, we know it'll look like symmetrical if we do the image of it. So if we moved over 1, we went up 2, so right here. And if we moved over 2, we're right here. So this is really high up. And then we just kind of fill the graph in. And that is our function 2 bracket x plus 1 squared minus 4. Okay, so let's write x equals -1. And what is that? That is our axis of symmetry. Now we have two x-intercepts. So we have two x-intercepts. What is our y-intercept? Y equals -2 is the y-intercept. And now we have the domain. And the domain for all polynomials, and a quadratic is a polynomial of the second degree. So that is a very fancy way of saying the domain for a polynomial is all real numbers. So it is x such that x is an element of a real number, and we close our set brace. And the range is the y such that y is an element of a real number. Oh, I almost closed that. And it has a minimum, and that means y has to be bigger than -4, but it can also equal -4. It is and we close our set brace. So that's essentially how we do all transformations. We can also note that A, which is our leading value here, equals 2. And that means that it compresses it or stretches it out. So makes the, whatever, it just squeezes it, kind of squeezes it in this way. Or you can say it stretches it that way. It's the same thing. And it's positive. So it opens upwards. Cool.